Well, for our first question, we have to find the limit. So I'll rewrite this, the limit, as x goes to 0 from below of root of x squared plus 100 minus 10 all over x squared. And we cannot evaluate this directly because we'd have division by 0. What we will do, though, is use the difference of two squares theorem and multiply by 1 in the form of root x plus 100 plus 10 over root, this is root x squared plus 100 plus 10. And to reinforce the idea that this is a product, we'll put parentheses. And so we have the limit as x goes to 0 from below. And the product of these two, by the difference of two squares, is going to be x squared plus 100 minus 100, negative 10 times positive 10. And the middle term, of course, drops out. And downstairs we have x squared, and the quantity square root of x squared plus 100 plus 10. And now these values drop out, they add out, and we have the limit as x goes to 0 from below of x squared over x squared times the square root of x squared plus 100 plus 10. Now the x squareds divide out and we get a 1 here. And now we can let x go to 0 because we will not have division by 0. If we do that, 0 below of 1 over the square root of x squared plus 100 plus 10. And if x squared goes to 100, we just have the square root of 100 plus 10, but the square root of 100 is 10, and so this thing equals 1 over 20, and we've found the limit. And that's it. Well, here we have two problems to do. For the first one, we have to find the limit as t goes to 0 of sine kt over t. Gee whiz, if only we had a k here, then the limit of this thing would be 1. This quotient would be 1 as t goes to 0. Now let's put 1 there. We'll multiply by 1 in the form of k over k. Now, since this k is a constant, we can bring it outside the limit, and so we have k times the limit as t goes to 0 of sine of kt over kt. Now, the limit as t goes to 0 of sine of kt over kt is 1, and 1 times k is k, and we're done. Now for 2, we have the limit as x goes to 0 of x squared minus x plus sine x all over 2x. So we'll break this quotient up into 3 terms, and we have the limit as x goes to 0 of x squared over 2x minus x over 2x plus sine x, and I'm going to spread these factors out, 2 and x, 2x. So this equals the limit as x goes to 0. And one of the factors of x divides out, and we get x over 2. Here the x's divide out, and we get 1 over 2. Plus, here, sine x over x is 1 as x goes to 0. And we still have this 2 in the denominator, so we have a 1/2. Now as x goes to 0, this thing zeroes out. And what we have is negative 1/2 plus 1/2. And that is 0, and we're done. Well, now we have to, we're given this function, g of x, and it's a piecewise function, equals x for x less than negative 2, and b x squared for x when x is greater than or equal to 2. So let's graph each piece of this, or at least what we can of it. And so when x is less than negative 2, we've got g of x equaling x. So we'll graph that. And we'll graph it right up until x equals negative 2. In fact, we'll graph x equals, we'll let x be negative 2 here, and what we'll get back is for the y value is a negative 2. But we'll put an open circle there because negative 2 isn't in the domain of this. But nevertheless, the coordinates of this open circle are negative 2, negative 2. So good. Now we'll look at the second piece of the graph, and that is g of x for x greater than or equal to negative 2. G of x equals bx squared. And our task is find a value for b such that this the finished graph will be continuous. So we have to fill in this hole here and then continue on with the rest of g of x when x is greater than or equal to negative 2. And so that means, well, we know what the y value has to be. It has to be negative 2, and we know what the x coordinate is. It is negative 2. So let's look at g of negative 2, and that equals b times negative 2 squared, which equals 4b. So now we know that, and this is the y value when you evaluate g of negative 2. So now we know that 4b must equal negative 2, the y value here, in order to fill that in and be continuous. So negative 2, now dividing through by 4, we have b equals negative 2 over 4, or b equals negative 1/2. And that's the value of b we need, but just check it out. Let's replace b with negative 1/2. So g of x, and this is for the interval x is greater than or equal to negative 2. And g of x equals negative 1/2 x squared. And let's put a negative 2 in here and make sure for x, and make sure we get a negative 2 back for y. So g of negative 2 equals negative 1/2 negative 2 squared, which equals negative 1/2 times 4, which equals negative 2. And bingo, that's what we needed. So b equals negative 1/2. Now we'll graph this thing, and we can fill in the blank, and we know it has a vertex at the origin and opens down, and there we have a continuous function.